Hello, my name is Imran Aslam. Today I am going to give a demonstration on Turbo Expander Re-Compressor Performance Evaluation application. First of all, I will explain the installation procedure of this application from the setup file. If you have already downloaded the setup file from my website www.petrosoft.com, then you can simply double click on the setup file. The setup utility wizard will be launched on your computer. From the language section, you can select the appropriate language and then press the OK button. It will take you to the license agreement page. Again, by selecting the appropriate option and pressing the next button, it will take you to the information page. Again, here you can press the next button. Then it will take you to an additional page where it is asking you to create a desktop shortcut of this application, where you can specify to create a desktop shortcut so that you can run the application anytime in future straight from your desktop. Again, pressing the next button will take you to the final step of the installation window, where by pressing the install button the application will be installed immediately on your computer. Since I already have the application installed on my computer, I will simply cancel out this utility wizard and then go to my desktop, where I have already saved the desktop shortcut of this application. From this desktop shortcut, I will just simply double click on this desktop shortcut. The application will launch on my computer, on my screen immediately. On the top section there is a menu bar. From the menu bar, on the left hand side, the first menu tab is the file menu tab. Under the file menu tab, you will have three sub options: the new sub option, the save button, and the exit button. By pressing the new button, you can actually initiate or launch the new instance of the application. For example, if I close the application, then I can simply press the new button to launch the new instance of the application. Now the save button can print the results of this application into the PDF file format, and you can save it on your computer. The exit button is to close the application. The next button is the about button on the menu bar, from where you can read about the brief of this application and the developer's information. The next button is the help menu button. By pressing the help menu button, the application manual will be launched in a PDF file, which you can read it out with further guidelines and the procedure. A complete narratives and description for each section with a detailed explanation is provided with the pictorial representation, so that user can review this manual anytime during the use of the application to find out more in detail about each section. Now I will go back to the application. Now on this application, basically it has several different pages. The very first page on the left hand side is the input page. The next page on the right hand side, on the left hand side, is a result page, where after the calculation the results are calculated and shown in the respective fields, and so on. All the different pages are representing different informations regarding the results. So we will go through each page after once the calculation are performed. So let me go to the input page here, and let me explain the main requirements or the process variable required as the input in this application. But before going to the required input section or input page, I will simply go to the schematics of this Turbo Expander Re-Compressor machine. I assume that the users are already aware of this working principle and the operation of the Turbo Expander Re-Compressor unit. So I will not go in much detail or technical detail about the working principle of this machine, assuming that the user already aware of the working principle of this machine. However, I will explain, just go over the main schematic inlet outlet streams to explain about the machine. So basically, this machine has two rotating parts. The one part is called the turbo expander wheel, and the second part is called the turbo recompressor wheel. Both the wheels are mounted on a single shaft, and the expander wheel is driven by the inlet flow of the gas, which is at a high pressure inlet flow of the gas coming to the expander. It strikes the expander blades, rotates the expander at a higher RPM. In return, the potential energy or the pressure of the gas drops uh, while turning the blades of the expander, resulting in the pressure drop across the expander. With a high pressure drop, a large temperature drop due to the Joule-Thomson effect also created, and the resulting outlet temperature drops to a very low temperature value after when the gas passes through the expander side. So the gas loses its potential energy, and that energy runs the expander wheel and convert it into the mechanical energy, and the expander wheel then further rotates the shafts, which rotates the compressor side wheel, which is mounted on the other end of the shaft. So so this is how this this machine works to liquefy the gas or the heavier components from the gas stream. So when the gas passes to the expander, it loses its potential energy, drops its pressure and temperature. That results in the separation of or the liquefaction of the higher components in the gas stream, starting from ethane, propane, butane, and C5 plus components are get separated out or liquefied at the outlet of the expander at a lower pressure and a lower temperature. And then after the separation of this vapors and liquid stream in the demethanizer column, the resulting vapors leaving the methanizer column or the gas stream passes through to various heat exchangers, and then goes to the suction of the compressor side, where the compressor again adds energy to this low pressure gas to a certain higher pressure and deliver it to the downstream unit. So this is pretty much the very basic high level explanation of the schematics. Now I will go back to the input section now and explain the required inputs for this application in order to run the application. Now the first section here in the input page is the OEM data or OEM design data, where the user need to provide the design information of the expander and the compressor wheels or the compressor sides. This information can be pulled out from the vendor's manufacturing data or vendor's manual or a design data sheet. The first information is the speed of the expander and the compressor at which it is designed for at the first time, and the flow or the maximum flow at which these two sides or wheels are basically designed for. Again, the unit of measures for the flow can be selected as appropriate by the user from this drop down list, and the required flow values can be given in the respective fields of the expander and compressor section. Also, the temperature, pressure, gas molecular weight needs to be provided or can be retrieved from the vendor's manual and provided here as an input. The next section is the compressor speed section. Okay, before that, the compressor efficiency section in the OEM design data. Again, this information can be given or retrieved from the vendor's manual. If this efficiency or the compressor performance efficiency point or efficiency percentage is not given, then the user can simply select the checkbox of empirical equation, use of empirical equation. Then the application will calculate this information by itself. Now the next section is the compressor speed. Again, the compressors or the recompressor side of the machine may be designed to operate within a set range of minimum to maximum speed values, which again is provided by the vendor, or this information is generated by the vendor performance data. The user need to specify a given range of speed at which this unit assembly is supposed to be or likely to be operated or operating at the site. So here the user can specify the minimum to the maximum speed percentage value. However, the speed value in the RPM can be calculated or will be calculated by the application itself. The user does not need to provide this information separately. So arrange for a 7 set of speed conditions or the speed values from minimum to the maximum is to be provided in the compressor speed section. Now the next input section is the compressor's 100% performance curve OEM data or the vendor's data. So now when this expander or this compressor is designed, it may be designed for a certain design parameter, or the vendor has already evaluated or estimated the performance data of this compressor at a certain 100% load condition, and certain important process variables or process parameters has already been defined by the vendors and will be provided in the vendors provided data sheet or manual. Those process parameters are flow, polytropic head, pressure ratio, power, discharge temperature, and mass flow rate. So here the user need to provide the performance data curve for one speed only, which is representing the 100% speed load condition or the best efficiency speed load condition, which is estimated by the manufacturer. So this information again comes from the manufacturer or vendors provided manual or the data sheet. Sometimes the vendors provided only the flow and the head values or the performance curve related to the flow and the head only, whereas the other performance data curve or performance data for the pressure ratio, power, discharge temperature, mass flow rate, etc. are not normally provided or evaluated by the manufacturer, or is simply not given in the vendor's manual or the data sheet. Then in that case the option is provided to the user here for the remaining 4 parameters. The user can select this empirical calculation checkbox. By selecting the check boxes here, the application will calculate these 4 process parameters by itself through the inbuilt thermodynamic algorithms. So as a minimum, the user need to provide the conditions or the data for the flow and the head values straight from the vendor's manufacturing data. Also the total number of 10 data set values need to be provided or can be provided in this application for these process parameters. But again, sometimes the information is not available to that extent. However, as a minimum, 3 dataset values needs to be pulled out or provided by the user, which can be retrieved from the vendor's manufacturing or the performance data curve. So as a minimum, 3 dataset values needs to be provided. So in this case, if I have only 3 values, so basically if I uncheck the data point number 4 onward, I can simply specify only 3 dataset values and neglect the other values over here. However, the application will calculate all these values up to 10 dataset values automatically through the inbuilt algorithms. Now moving to the next input section, which is the operating conditions of this turbo expander recompressor assembly. Here the site condition or the site based conditions needs to be provided at which the assembly is supposed to be running or likely to operate at your site. Again, the expander inlet flow needs to be provided, and the required unit of measures can be selected from a given list of most appropriate or a common unit of measures, and the respective flow value can be provided or filled in into the required field. Similarly, the expander pressure, temperature, compressor temperature and pressure needs to be provided. Here the compressor discharge pressure, the discharge pressure requirement is given as an option. Here the user can check this checkbox for this compressor discharge set pressure if the compressor is operating or likely to operate, which is the case in most of the cases. The compressors must be operating at certain discharge pressure conditions. So the checkbox, the user can tick the check boxes and provide the required set pressure value in the respective field for the discharge set pressure of the compressor. Now the next is the compressor efficiency for the side-based condition. If it is not known or it is unknown, then the user can simply check the apply empirical equation checkbox so that the program can calculate this information by itself. Then again the expander inlet and the compressor inlet gas molecular weight needs to be provided by the user. The pressure drop between the expander outlet assembly up to the compressor inlet assembly needs to be provided, which is again different based on the site conditions. Also the low temperature separator at the outlet of the expander, or the vapor fraction or the separation of the gas fraction is provided by the user. Also the demethanizer vapor fraction. So when this outlet stream from the expander goes to the methanizer column, then a certain fraction of vapors leave out from the column, which is mostly the methane gas, and the heavier since the heavier ethane, propane and butane are already liquefied and separated out in the vessel in the column. So again this vapor fraction needs to be provided by the user, and the demethanizer reflux stream percentage needs to be provided over here. The other additional information needs to be provided, given as an option, which is an excess gas coming into the compressor side or any gas side stream leaving from the inlet of the compressor side. So in some cases at some sites compressor may be getting some side stream or a side inlet stream from the other processing units, which can be provided as an additional or excess gas here in this field, and again the unit of Myers can be selected from the drop down list here. Similarly, if there is any side stream of the gas extracted or leave from the main inlet stream of the compressor or withdraw from the compressor inlet side, then again the user can provide this information in the respective field, and the unit of Myers can be selected from the drop down unit of Meyer list as appropriate. Then the next input is the surge flow safety margin. So if the surge flow safety margin normally provided or is likely to develop, then the user can provide the information here. Here the anti-surge valve auto control or a manual control option is provided here, which is directly related to the discharge pressure of the compressor set pressure. So if the user specify the discharge pressure as a set pressure value, then this anti-surge valve auto control will be active, which means that the compressor supposed to be operating at the site in a automatic anti-surge valve auto control mode, so that to maintain the required discharge pressure against a certain inlet or incoming flow rate. If however the set pressure discharge set pressure set point is not provided or is not checked on the set pressure discharge set pressure option, then the user can uncheck or convert this automatic control of the anti-surge valve into a manual control by simply uncheck the box here. So this information can be changed or altered any time during the application by the user. Now moving to the next input section, which is the gas composition or the sour gas composition of the expander inlet gas and the compressor inlet gas, where if the inlet gas to the expander side or the compressor side has some sour gas components which are CO2 or the H2S, then the user can specify the composition in this respective fields over here. So once all this information is provided, the entire input section is completed and the application is ready to run. So once all the information is provided, the user can simply press the calculate button. By pressing the calculate button, the application will perform all the calculation, and all the respective result sections will be populated with the values, and also in the input section or the input page, all the missing information will be calculated at the same time by pressing the calculate button. Now here, for example, as at the start I mentioned that the four process parameters, pressure ratio, power, discharge temperature and mass flow rates, are not provided by the vendor, or simply we do not have the information of this four set of process variable, then simply checking this empirical calculation method. By pressing the calculate button, all this information is calculated and populated here on the same section automatically during the calculation. Now when the calculation are done, the message bar will turn green with a caption OK on it, which means that the calculations have been done and no error messages were found during the calculation. If however the user provided any incorrect value or any incorrect data in the input field where a numeric value needs to be or supposed to be provided, then the calculation will stop with a label with a red color background saying that the user need to revise or update the incorrect values in the input section. And again, by pressing the calculate button, the calculation will resume and refresh and produce the results once again. Now moving forward from this to the next section, which is the results section. When I go to the results section, the user can find out and review the calculations both for the expander side calculation and the compressor side calculation separately in the respective fields. On the expander side, the calculations regarding the operating speed, discharge pressure, the required or side base condition, discharge temperature, pressure ratios, isenthalpic heat energy, compressibility, heat capacity ratio, power are calculated by the application. Also on the compressor side, the compressor calculation section, the user can review all the calculation related to the compressor side base flow rate and the OEM base flow rate at which it is designed for, and the suction pressure, discharge pressure and other important related information are all populated in the respective field. Worth mentioning here, the anti-surge valve state or the status. If for example the turbo expander or recompressor or the compressor is operating in a surge condition or a surge flow condition, then here in the compressor calculation section, the anti-surge valve state or ASV status will be shown as open or a close for any given condition under the side base condition information. So at this moment, for the side base, given flow of 231 million standard cubic feet per day for a given set of operating speed and the other input variables, the anti-surge valve condition shown as an open condition, and again the total flow that is passing through the anti-surge valve also calculated and shown in the respective field, and the discharge flow of the compressor or through the compressor in terms of million cubic feet per day is shown or calculated in the respective field. Also the power required by the compressor is calculated here in the compressor calculation section. Similarly, the calculation is done for the low temperature separator and demethanizer results section, where the total inlet flow, demethanizer reflux flow rate, and other information on the LTS flow and the demethanizer outlet flow is also calculated. Also, there is another warning section is developed, where if there is any warning message found during the calculation, it will be populated here in this section in the under the warning section. Now moving to the next page, which is the site schematics page. Here the user can simply take a quick look at the major components, input variables or output variables. All the major information or main information of the temperature, pressure, flow is populated at each stream after the calculation is done, and the user can simply review all this information at a glance from this schematic window. Here an additional option or an additional feature is provided, which is the dynamic calculation feature of this application is provided to the user here under the expander dynamic control window, where the user can simply alter or change the inlet incoming flow rate to the expander side in order to see the corresponding impact of all this process parameter on each different stream. For example, the user can simply scroll this button here to change, to increase the flow or decrease the flow. As you can see, if I change the flow, if I increase the flow, for example, the corresponding numbers or the calculated values are changing dynamically on this graphics or schematics for the quick analysis and the generating the ideal or the optimized operating conditions of the site. So again, the user can increase or decrease the flow or the inlet flow to the expander while maintaining the other inlet or the input conditions the same as explained or mentioned or given by the user in the input page. Here the user can simply change the flow conditions of the expander inlet dynamically to change the site conditions, as you can see over here. Now moving to the OEM schematics drawing, which is basically representing the initial or the design condition of the compressor. Again, the main OEM design information or a calculated information for a given set of condition based on the site is again calculated for this OEM based schematics as well, where the user can review the inlet flow, temperature, pressure, outlet flow and temperature and pressure of the expander and the compressor respectively. Now moving to the next result section, which is the OEM performance data set values. So here the application has calculated the performance data curves for the OEM for all the speed range from the minimum to the maximum. Also the stone wall curve and the surge curve data for the compressor side is also calculated for the OEM base case condition. Remember here the user has only provided one speed value, which is the 100% speed range value from the vendor's manual, whereas the application has developed the performance curves for the entire speed range also for the OEM base case condition. Similarly, for the site based performance data, the similar set of calculation for the entire range of speed as provided by the user is generated and shown in the tabulated form in this. So here in this site performance data tab or a page, the user can review the performance data set or data values for the entire speed range, including the stone wall curve and the surge curve data or the performance curve, also presented in the tabulation or the tabulated form. Now the next section is the performance curve section. In the performance curve section, there are further different graphical representation of different process parameters are shown or presented in the graph, comparing the two performance curves together, one for the OEM based performance curve and the second is for the site based performance curve. So both the performance curves can be reviewed and compared side by side under this performance curve page. So the very first page under the performance curves is the performance curves of the compressor for the flow versus head curves or the polytropic head for both the OEM based and the side based curves. And the second set of page is the performance curve between the flow versus discharge pressure. Again here both the OEM based and the side based performance curve are shown side by side. Similarly, the performance curve for the discharge temperature and for the pressure ratio curves and for the flow versus power curves are all generated for all these 6 or 5 basic parameters together for the review. So again the user can review all this information and change the input conditions as required. Here going back to the flow versus head curve, under this curve condition or in the graphical page, and there is another set of dynamic control or expander dynamic control utility is developed and shown and given in this section here, so that the user can actually visualize the operating point, which is shown on the graph with a little triangular dot that is representing the operating point of the compressor at the site, both for the OEM based performance curve and for the site based performance curve. So in order to review dynamically the operating point or the changes in the operating condition or the operating point of the compressor, the user can use this expander dynamic control utility here, which is given under this graph, where the user can simply change, increase or decrease the flow rate, inlet flow rate to the expander. While doing so, you can review, as you can see, the operating point is dynamically moving across the performance curve. So this is the point where the user can further optimize or change the conditions of the site base in order to run the expander utility or expander unit at the optimum conditions. Now moving back to the input section once again. Now here if I specify here in the input section site base condition, I require the set pressure of the discharge of the compressor. At the discharge of the compressor, I specify or check this discharge pressure requirement or the set pressure requirement at the discharge of the compressor and keep the anti-surge valve in the auto control mode. Then again I press the calculate button. Now this time I will go simply back to the performance curve data. Under the performance curve tab, I will go to the flow versus head curve, and again I can change the inlet flow or the required flow to the compressor to the expander side. Here by doing so, I can see the movement of my operating point across this performance curve envelope, in order to see how the compressor is performing under a different set of input conditions. So here this is how the user can change the inputs, and then from the dynamic control of the expander, the user can actually visualize the operating points or the operating condition of the compressor dynamically from this graphical representation page, or also the same action can be performed from the site based schematics expander dynamic control. From the top, as you can see, you can simply change the flow and the required set of values or the information at the site will change accordingly. So in this way you can optimize or set the required operating or optimum conditions at the site for this application. Now this is pretty much all the main features given in this application. Now once you are okay with the calculation and you wanted to take the print of this print the results of this calculation, you can press the print preview button. Once you press the print preview button, the print preview window will open and all the information or the result pages will be shown in front of you. So once the print preview is completed, you can see the print preview window. A total of 25 page report is generated, including all the results and the input section, which by the application, which you can simply review one by one and change the conditions accordingly. Once you are okay with the results, you can simply press the print button here to print out the results into the PDF file format. Once you print the result, the PDF file format results will simply be printed, and you can review the results in the PDF file as shown on my screen over here. Again, the 25 page report is generated for all the results with all the performance curve graphs, and the tabulated data are all presented and printed out in the PDF file format. Now this is pretty much all about this application. Hope you have liked the video, and thank you very much for your time and patience. Please subscribe and like my channels and visit my website for more chemical engineering applications. Until then, take care. Bye bye.